So that's our first step in our asset pricing theory. And what we need to do next is to talk about the equivalent of budget constraint, which is the portfolio locus. So that takes us to section 7.4. And this is on diversification and the measurement of risk. And what you should do is read chapters 7 and 8 in the book. Now, just as we can represent people's taste, we can also start representing stocks on our diagram of mean and standard deviation. Okay, so we might take a stock A, its mean would be here, and its standard deviation would be here. And we might have another stock B. Suppose, for the sake of illustration, it has the same standard deviation but a higher mean. If you had to put all your money in stock A or stock B, which one would you choose? B. It's got a higher mean, the same standard deviation. Because we know you don't have to put all your money in A or all your money in B, what else can you do? You can mix it. You can form a portfolio. So let's look at an example and see what happens if we have two stocks and we form a portfolio. Let's suppose that we have 4 states of the world, 1, 2, 3, and 4, and let's suppose they're equally likely. We've got 0.25, 0.25 for all 4 states. Suppose the outcomes, the payoffs of stock A in state 1 is 1, 2 in 2, 3 in 3, and 4 in 4. B, we have in state 1, 5. State 2, we have 4. State 3, 3. And state 4, we have 2. If you calculate their characteristics, the average of A is 2.5. The variance is 1.25. And the standard deviation is the square root, which is 1.12. B has the expected return of 3.5. The variance of 1.25, and the standard deviation is the square root, which is again 1.12. If we look at the covariance, what do you think the sign's going to be? Negative, because when A goes up, what happens to B? It goes down. So they move in opposite directions. We know that's negative covariance. And if you work it out, it's minus 1.25. So in terms of our diagram, we've got this situation here. This is our 1.12 for the standard deviation of A and B. The mean of A is 2.5, and the mean of B is 3.5. Suppose we mix and put half our money in A and half our money in B. Let's call that D for diversification. What do we get? State 1, we get how much? Half times 1 plus a half times 5 is 3. Half times 2 plus a half times 4 is half 3, and half 3 is 3. Half 4 and half 2 is. So what's the mean? Mean is, what's the variance? 0. And so the standard deviation is 0. So if we're on this diagram, we're here at 3. This is D. And we're right on the axis. Which do you prefer, D or B? Depends on your risk aversion. Which kind of curves are you going to prefer D with? The curves when they are which? If they're steep, you're going to prefer D. So if you're risk averse, you're here, like that. If you're not very risk averse, so your curves are flat, you're going to prefer B. So we're going to get something like this. Does everybody see that? Now, we don't just have to have 50-50. What are the other things we could mix A and B with? Many other proportions that we could use. For example, we could have a portfolio with 0.25 in A and 0.75 in B. Now we could go through and do an exercise like we did here for the half-half, but it takes a fair amount of time, and so instead what we can do is to take our formulas that we developed earlier on, and we can find the mean and the standard deviation in that case. So we know that our formula from earlier on was that means add. That was just our pi1 ex1 plus pi2 ex2. So the portfolio mean is going to be 0.25, that's the pi1, times the mean of A, which is 2.5, plus 0.75 times 3.5. That's the mean of B. If you work it out, it's 3.25. So we're going to be somewhere like this at 3.25. If we look at the portfolio variance, we know our formula for that is this expression here, pi1 squared variance of x1 plus pi2 squared variance of x2 plus 2 pi1 pi2 covariance x1 x2. So what we've got there is 0.25 squared times the variance of A, which is 1.25, plus 0.75 squared times the variance of B, which is 1.25, plus 2 times 0.25 times 0.75 times the covariance, which is minus 1.25, and if you work that out, it's 0.3125. So the portfolio standard deviation is going to be the square root of that. And if you calculate the square root of 0.3125, you get 0.56. So our point here of 2575 is somewhere like this. It's halfway between 3 and 3.5, and halfway between 0 and 1.12 at 0.56. If we've got half-half in terms of the distances, what do we know about the shape of the line we're tracing out? If everything's proportionate, it's going to be a straight line. Exactly. So in fact, if we go through and we calculate all the other possibilities, we're going to trace out this straight line. Here we've got 100% in B, 0 in A. Here we're 75 in B, 25 in A. And here we're 50-50. What do you think we are somewhere like this? How much would that be in the portfolio? 90% in B maybe? 10% in A? If we're here, it might be, how much in B? 60 and 40. Here we're 50-50. If we go more in A, less in B, what do you think we're going to trace out? Another line which is like this. Okay, so this is our portfolio locus. By mixing A and B, we can get anywhere on that line. Which is the part of the line we're interested in? Would you ever choose something down here? No, it's always better to be on the top line. Any questions about that?